Welcome to qnawire.
Here we want to draw the chair conformations for the following compound. First of all, remember that whenever we have this type of bonds, these are going to be looking down the down the plane. And if we have bonds that look like this, they're going to be looking up the plane. That means that each of them are going to be on either, this needs to be on a down equatorial position or a down axial position, and this one corresponds to either an up axial position or an up equatorial position as well. In this case, all of the ligands that we have here are going to be looking down, so they need to be pointing down in our cyclohexane conformations. So the first thing that we need to do is to label the carbon atoms 1, 2, 3, and 4, and do the same thing in our chair conformations 1, 2, 3, and 4. Remember that whenever we do the ring flip or ring inversion, the labeling of the atoms is going to switch by one position. Okay? So now the only thing that we need to do is to put each substituent into the correct position. So bromine on carbon 1 is going to be looking down, so it corresponds to equatorial down position over here, equatorial down position. Next up on carbon 2, we're going to be looking down as well, so this is going to correspond to an axial down position. So this is going to be our CH3 coming from that part. This is an axial down position. And all the way to carbon 4, we're going to have also looking down. In this case, it corresponds to also an axial looking down position. CH3, axial looking down. Now, when we do the ring flip, we're going to be doing exactly the same thing, but notice that now, whatever was in an equatorial position, now is going to be in axial and vice versa. So, carbon 1, bromine, is going to be now in an axial down position. So, this is going to be our bromine atom, axial looking down. On carbon 2, we're going to have, in this case, corresponds an equatorial looking down position. So, on this version, what this is going to look like is, as it was going down here, this CH3, this is an equatorial looking down position. And finally, on carbon 4, we're going to have also an equatorial down position. So, down here, let me erase a little bit of the equilibrium lines that we have here to have more space. And there's going to be the position for CH3, for the last substituent that we have. And this is going to be as well an equatorial down position. So notice that upon ring inversion, what is going to happen is that everything that was in equatorial goes into axial and vice versa, and the most stable configuration is the one in which you have most of the substituent in equatorial position. So with that information, we know that the favored conformation is going to be the one on the right, because we have two substituents on the equatorial positions. Remember that axial positions are not going to be preferred because we're going to have a 1-3 axial interaction in the cyclohexane rings. In this case, what that interaction looks like would be the interaction of both of these CH3s in between 1, 2, 3. Okay? So with that, it would be all. Let me erase these lines just for you to have the actual conformations. So that would be all. Thank you very much and have a good one.